Hello everyone. In this video we will discuss the definitions of P, NP, NP-hard and NP-complete problems, and this categorization is from a perspective of algorithm research. So this is in fact a research topic, and we will be just covering the surface level definitions or top level definitions of these categories, and we will not be getting into the inner details of these classes. So the first definition is a P class problem. Okay, so we know several algorithms which solve in polynomial time. Okay, what is polynomial time? That is, these are algorithms which can be solved in time proportional to n, or n square, or n cube, or log n, or n log n. Okay, problems which can be solved in polynomial time complexity are called a P class problem. For example, for linear search we have a time complexity of n, and for a bubble sort we have a time complexity of n square. For multiplying two matrices of dimensions n by n we have a time complexity n cube, and for binary search we have a time complexity of log n, and for merge sort we have a time complexity of n log n. Okay, so the problems which can be solved in polynomial time is known as P class problems. Okay, now we have another set of problems which are using exponential time. So the one we have discussed so far is the 0-1 knapsack problem or the superset problem. So those problems are using a time proportional to 2 raised to n. One familiar example which comes under the category of exponential time is the Sudoku problem. Okay, so the Sudoku problem or the 0-1 knapsack problem or the superset problem all are solved in a time proportional to 2 raised to n, or those are problems with exponential time complexity. The problem with exponential time complexity is the value of 2 raised to n will be very large compared to the polynomial time when the value of n increases to a very high value. So these problems which has an exponential time complexity will take a very long time in terms of billions of years to be solved by computer when the value of n is getting very large. So the main focus of the algorithm researchers is, can we have a solution or can we have a problem in terms of polynomial time which currently has a solution in terms of exponential time. If we can solve a Sudoku in polynomial time, that will be a bigger leap in the algorithm research. So if that can be done, then a solution for a Sudoku can be found in a reasonable amount of time. Okay, so this is what algorithm researchers are focusing on. Can we have a polynomial time complexity type solution for a currently existing exponential time algorithm? So coming to the P-class definition, a P-class problem is a problem which can be solved in a polynomial time. Okay, now the next category is NP-class problems. A problem which cannot be solved in polynomial time. So we are out of this category, but its solution can be verified in polynomial time is known as non-deterministic polynomial or NP class problems. So we cannot solve a problem in polynomial time, but its solution can be verified in polynomial time. For example, if you take the case of Sudoku, the Sudoku problem is very hard to solve, but you can verify very easily a solution if a solution is given. You can check whether it is right or wrong. So that process is very easy. But finding a solution for Sudoku is difficult. So that will be taking exponential time. But its solution can be verified in terms of polynomial time. Another example is finding the factors of a number. If the number is very bigger, then it will be very difficult to find the factors of a number. Okay, but once a factor is given, you can just multiply those factors, then you can verify those numbers very easily. Okay, a problem which cannot be solved in polynomial time but its solution can be verified in polynomial time is known as non-deterministic polynomial or NP class. Now we will discuss what is a non-deterministic polynomial class. You can see that here I have given an algorithm n search, and which is taking an array in integer and a number as key. Okay, our aim is to search for a key in an array of size n. So first what we are doing is we are finding j equal to choice. Okay, that is, we are executing a function called choice and it is giving me the number, and this number is supposedly the index of the number that we are searching for. Now we will check whether the key is equal to a of j, that is the number at the location j, and if it is true we will write the index and we will call a function called success, that is we have found that number. Otherwise we will write 0, then we will call a function called failure. Suppose that I have an array and it has several numbers, let's say 4, 9, 1, 2, 6. Okay, and the indices of this will be 0, 1, 2, 3 and 4. And if I'm going to search for a number 2 in this array, so this choice function is giving me magically the number 3. That is, it is showing me the index of the number 2 is 3. Okay, so we will be checking whether at this location the number 2 resides. So we see that the number 2 is there, then we will say that we will write the index and we will say that the search is success. And the question is, how can this function magically give the index of the number that I'm searching for? Okay, so this is not deterministic. Okay, but if you include this non-deterministic statement in this algorithm, then this algorithm becomes a non-deterministic algorithm. Okay, so for some exponential time consuming algorithm, we can have non-deterministic algorithm where we'll be writing some imaginary functions which will be reducing the job. Okay, so if that job is done, then the problem becomes a polynomial type problem. Okay, so that is the meaning of a non-deterministic algorithm. If such an algorithm can be written, then that algorithm take a non-deterministic polynomial time, which means that it is taking polynomial time, but it is non-deterministic because it has some non-deterministic statements. And another point is P is a subset of NP. Okay, so we have a broad category called NP type problem, which is taking a non-deterministic polynomial time, which currently has exponential time complexities. As and when you find a solution in terms of polynomial time, and it is moved to a category called P. Okay, so P is a subset of NP. Now another term that we need down the line is the term called reduction. Okay, so if we convert a problem, say problem A to problem B in polynomial time, then problem A reduces to problem B. Suppose that you have two different problems A and B, and if somehow you can convert a problem A into problem B in polynomial time, then we will say that the problem A reduces to problem B. Let's say A and B are two problems which is taking a complexity of exponential time, and if you can convert the problem A into problem B in polynomial time, then we will say that the problem A reduces to problem B. Okay, now if a problem A reduces to problem B, which means that if we can solve B in polynomial time instead of exponential time, we can say that, or it indicates that problem A can also be solved in polynomial time. Okay, so that is a statement written over here. If we can solve B in polynomial time, then that indicates that A is also solvable in polynomial time. So this is called reduction. Okay, so the significance of reduction is, suppose that I have an algorithm in NP class which has a complexity of 2 raised to n or exponential time complexity, and we developed a new algorithm by which we can solve the same problem using polynomial time. But if we have another problem which reduces to the problem that we have solved, then that problem can also be solved in polynomial time. So that is what is written over here. That means that if you have two problems A and B, if A can be converted into B and if B can be solved in polynomial time, then similarly A can also be solved in polynomial time. Then we are going to the next definition, that is NP hard class. These are problems that are at least as hard as the hardest problem in the NP class. So the NP hard class contain problems which are at least as hard as the hardest problem in the NP class. Okay, so the NP hard class contain the more complicated problems than the NP class. The NP hard problems contain which has no solution at all. There are several problems which doesn't have any solution, so those problems are included in NP hard. Now NP complete problems, this is the final definition. A problem is NP complete if it is NP and NP hard. NP complete is the intersection of NP and NP hard. Okay, so we have the NP class here and we have the P class here, and the intersection between NP and NP hard is called the NP complete. Okay, so these NP complete problems will be the hardest problem in the NP class, and it will be the least hardest problem in the NP hard problems. So this video is to discuss the definitions of this term, and we have just gone through the top level definitions. These are terms which are used in algorithm research, and with that I'm stopping this video, and thank you very much.